So far in our examples of solving linear systems of equations, we've had a unique solution to the system. But I mentioned that it's also possible there's no solution or that there's many solutions. So let's look at the other two cases. Now if we use row operations to get to row echelon form, and that form looks like, let's say, 1 something 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 something, and then 0 0 1 something something, and then 0 0 0 0 1, then there's no solution. We can see that by looking at the last equation. So if we use row operations and get this, then there is no solution. And the reason is, well, let's look at this last equation. What is it saying? It's saying that 0x1 plus 0x2 plus 0x3 plus 0x4 equals 1. But there aren't any numbers x1, x2, x3, and x4, so that if you take the zero linear combination of them, that you get 1. Because this is going to be 0 plus 0 plus, this left-hand side is 0. We have 0 equals 1, which is impossible. This is impossible. So that's how we realize that there's no solution. Now if we use row operations and get something like this, then there's going to be a unique solution, because we can solve for x3, use that to solve for x2, and use those two to solve for x1. So that's what we've been doing mostly in examples. Notice that we're using every column with a 1 in it, even though technically some of these ones could appear a little bit further to the right. They don't have to appear first column, second column, and third column. And when we skip a column, that's precisely when there's infinitely many solutions. So when we use row operations and get, let me do a specific example here without stars. Something like, let's say 1, 4, negative 1, 0, 3, 0, 1, 2, 2, 6, 0, 0, 0, 1, negative 2. Then there are infinitely many solutions. So let's go through and see what we can figure out about x1, x2, x3, and x4. By the way, this column doesn't have one of those leading ones in it. We've got a leading one here, leading one there, and then leading one all the way over here. none in that column. All right, well, we can see from the last equation that x4 equals -2. That's what the last equation says. And plugging that into the previous equation, that says that x2 plus 2x3 plus 2x4, which we know is -2, equals 6. That is x2 plus 2x3 equals, this is a -4, add 4 to both sides, and we've got 10. So we don't have enough information to say exactly what x3 is in terms of just x4, because there's this other variable here. So let's let x3 be some symbol, let's say t, and continue. So x3 equals t, and then pretending we know what x3 is, then we can solve for x2 in terms of that. So x2 is, if that's t, x2 is 10 minus 2t. And x1, the first equation says x1 plus 4x2. So x1 plus 4, x2 is 10 minus 2t. Minus t, because x3 we're saying is t, equals 3. And that means that x1 equals, let's say we've got 40 here. 3 minus 40 is -37, and -8t minus t is -9t. And then if we add that to the other side, we have plus 9t. So it turns out that any value we plug in for t, so any value we plug in for t is going to give us a value of x3 that's going to determine what x1 and x2 are. And x3 is a special variable here that can have any value, so it's called a free variable. It's not constrained by what the other variables are. And the free variable corresponds to a column that does not have a leading 1 in it. So we have the solution set x1 is -37 plus 9t. x2 is 10 minus 2t. x3 equals t, and x4 equals -2. You can also write this as, we can take all the t's and put them apart from the constants. So this is -37, 10, 0, -2, plus t times 9, -2, 1, 0. if for some reason we wanted to take the t's and separate it out so we can look at it with the t part and the non-t part, in case we think that's easier. Now finally, I want to say something about another system of equations. So this is infinite because any value of t gives us a different answer. Plug in 1 for t, 0 for t, 6 for t, 37 for t, and we get different answers. So there's infinitely many answers here. And then finally, I just want to point out one sort of easy thing. And that is that the system ax equals 0, and by 0 with a bar in it, I mean vector of all zeros. This always has at least one solution, and that is x equals a vector of all zeros. So for example, if we have 2x1 plus x2 minus x3 equals 0, and x1 plus 6x2 plus 4x3 equals 0, it's easy to see what a solution of this equation is. So if we said x1, x2, and x3 equal to 0, then we get 0 and 0. That's probably not all the solutions, but it's one easy solution. The end.